Okay, so welcome back to episode 2. I just got the same program that I had at the end here. Just want to check everything's going okay. Alright, so nothing's showing up at the moment, but that's because we haven't output it using either printf from the standard IO function, from the standard IO library, which is the directive which is involved in pre-processing directives, which is identified by the hashtag. Okay, so what we need to do now is we want to print these. We want to be able to actually calculate the dimensional weight. So what we're going to do now is we're going to do our print statements. So first of all, we want to say what the dimensions of the box are. So we'll open our string here. So dimensions. Now, what we need to do is we need to once again set the placeholders. And as you recall, we initialized the variables height, length, and width to be integer values after we declared them, of course, first. So what we need to do is we want to put our value in here. So obviously we could just type it in, but we want to actually get it from the variable. So we're going to do, so this is going to be, so we're going to do, it's going to be length, width times height. So it's going to be 12 by 10 by 8. So we want to put, so we'll put the 12 there, and then that's going to be by the width. The width comes second, I believe. Yeah. So the width, and then the height. Okay, and then of course we want to go move to the next line, like always. Okay. Now once we put the comma in there, then we can define the variables. And hopefully spell them right. Okay, let's just type them in. Okay, so we basically said there we're going to have 3 different variables, which I've managed to spell length twice incorrectly. Wow. Alright, so I think that's all spelled correctly now. Alright, so let's go. So there's our. So we've defined all the different variables. We can put gaps in here, and I don't believe it actually makes any difference. Interestingly, you can see it actually gives a little tooltip about what type of variable we're dealing with. So we know that by using the D there, we've set the correct one for a integer variable. Okay. Okay. So the next thing to do then is to we need to get the volume. The volume that we've already set has already been calculated. It's already been assigned to the operator. All these operators have already been. All the processing has already taken place. Okay, so we're going to do another print, and we're going to do the volume. This is in cubic inches. All right, so we're going to put the volume here. Do a new line. And then we'll do the comma, and then we'll have the volume, right? Oh, interesting. The semicolon always has to be outside the bracket. That's not that interesting, actually. That's pretty obvious. All right. Looks good, anyway. So anyway, this should work. So and then we can finally calculate the dimensional weight. Let's put this. Okay, so the dimensional weight here is going to be So the dimensional weight here This is going to be set in pounds. And then once again, it's simply, there's the placeholder, there's the new line, there's the closing of parentheses, there's the comma. Now let's have the variables, and there it is. Okay, let's have a look, see if we see what output we're going to get here. So we'll make sure we don't keep on forgetting to put these semicolons on the end of the line, because that is not a good idea. Okay, but all these could be actually be on the one line anyway, but whatever. Really? That went wrong? It's because I made this stupid thing. It's always the this slash. That's a backslash, yeah. It's always a backslash n. $12 by 108, that's incorrect as well. Yeah. So 12 by 10 by 8. Yeah, 12 by 10 by 8. And then we don't need a final x there. Alright, so now we should be in good shape. 12 by 10 by 8. The volume is 960 and the dimensional weight is 6. So we're taking that 960, we're adding 165 to it, and then we're dividing it, and we're dividing it to get that 6 result. So that all seems to be fairly common sense there. Like I say, we can change some of the values. So if we set the volume, for instance, if we got rid of this line here, set the volume to be 1. Let's test what we've actually put in the comment here. So we're going to set the volume to be 1. Alright, so what we basically do is we're basically making these three declarations fairly pointless because we're not using them. So now we say that the volume is 1, the weight will be 1. Let's have a look at that. Volume 1, the weight is 1, yeah. If the volume is 166, let's look at that. The weight is also 1, because remember it would be 331 divided by 166, which will be very, very close to 2, but it's going to truncate it, and it's only going to be 1. Let's have a look. Correct. Now if we change the volume to 167, we think the weight is going to be 2, because we're going to have 332 divided by 166, which should be 2. Let's just check that occurs. It occurs. Okay, so that's all been set up correctly then. And we're going to make. We don't want this to be like that really. We want that to be height times length times width. Okay, and we're back. We're back. Okay, good. So now what we need to do is so C is known as, so the value 8 is an initializer. Okay, yeah, fine. Okay, so what else can we do here? We can do slightly more with printf. So we've got yeah, we could now what if we wanted to do yeah, so one other thing we could do, yeah, let's go a little bit off piste here. What we could say, right, is we could have another printf statement. What we could do is we could say what is the perimeter around it. So the perimeter is simply Let's hopefully I haven't stretched myself too far here. That's the thing. Maybe I can't do that. Alright, let's just do the area. The area of the base. It's the area of base of box. So that's just going to be the length times width. That's really what I wanted to get to. Length times width. But what if we want to do with the length times width? So there's two ways we could do it. You can see that with the volume we did height times length times width. And then what we did is we assigned it to the volume variable and then we just simply printed it out. But what we could do is inside the print function, what we could do is we could do so we could do the area of the base of the box here, and then we put our placeholder here, and we want to go to a new line. But what do we actually want to put in there? Well, we don't always have to put in the actual a variable name. We could put in an expression in there. So we know what is this going to be? Length times width, isn't it? And I put this stupid thing the wrong way again. So I think might be able to do this. Let's try it. No, it didn't work. I wonder if it's got something to do. It doesn't have anything to do with the colon, does it? No, I've just done it incorrectly. Okay. What have I done incorrectly here? I wonder if it's getting confused because it's getting it's not able to access it again for some reason. Yeah, it doesn't make any sense to me. Maybe I can't put that in there. Can it not compute that on the fly, I wonder? Why is it only coming up with... Oh, it's because I used a fucking and sign. Bollocks. I was wondering what's going on there. Ampersand, rather. Alright, so... area of base of box. Area base is 120. Alright, so you can basically, so even though it's been fucked around with volume, it doesn't matter that I can still do that whatever I want. Alright, so the next thing to talk about then, okay, the next thing to talk about is to do with the input. So yeah, this is why I was using ampersands, because this is part of the next bit. Alright then, so the next point is to use inputs. So so this F means formatted, and you can see it does seem to have something of that. Alright. So yeah, so we need to we need to actually read input as well. Okay, so when we're dealing with input, we're going to need to use Scanf. So let's just get into it and stop. All right, so now we're going to change this to, we're going to make a better program. To find the dimensional weight, using user input now. So we're going to deal with input now. Okay. Right, we'll leave the test messages there just for fun. Okay, so we declare all the variables. Alright, but we don't have these constants here because they haven't been made yet. The calculations will still be the same though. Alright, so let's do another printf statement. Okay, so there we've got a gap. So that should be fine. Okay, so now we're going to do the scan function, right? So we've got these declared integers all ready to go. But what we want to do is, so we've got these empty integers, or there might be something in them, I don't know. But it seems like they're empty anyway. Even if they're not empty, they're saying I'm putting something in them. What the scan does is it uses the ampersand to take it from our so this was the placeholder, right? The placeholder was %d, wasn't it? As you can see when in this printf line. So it would take it from the variable length and put it and print it into the into our print function here. What this is going to do is a similar kind of thing, but it's going to take it from user input instead. So it's going to scan for the user input. So you've got to enter out a box, and then we're going to keep it within. It's strange to have inside a string, but I guess that's just how it is. And we're going to put it into height, and height, of course, already exists. So yeah, you can so you're putting it into something that already exists. You're putting something you don't know into something that already exists. And with printf, you're doing it's kind of the opposite. It's interesting. It's hard to explain. Like anything, I guess. Alright, so we want to do this for the length and the width. Okay. Remember to close it once we're talking about the next stage. Once we're talking about what's actually going to go into it. So the length. Okay. And then finally the width. Okay, let's just finish this up. Again, it's going to be the same sort of thing here. We'll close it, and we'll stick it into width. Okay. So the same sort of thing each time there, yeah? So then it can compute the volume in much the same way. And the weight can be computed in the same way as well. Okay. And we can print the volume out, we can print the dimensional weight out as well. Let's have a look at this. Not Control F, but that is useful anyway, I suppose. Let's build it. I'm not quite sure what line it's telling me I'm doing things wrong on. See declaration of Scanf. I assumed that Scanf was in the right place. I'm not seeing any problems with it, to be honest. Come on, what's wrong with that? Let me see if I can run it anyway. No? Why is that not letting me run it? That sucks. I may be able to run it anyway, but it's annoying that that's happened. I feel like I haven't got any of the variables incorrectly spelt though this time. No, everything looks perfect. I'm literally not seeing any problems here. Why can't I not get user input? This is what I'm finding annoying. There's nothing wrong with the declaration of it. They're integers, so I do %d. Should I get rid of my test message? I can't believe that's going to make any difference though. What is wrong here, man? Do I really have to put that in? Yeah. I don't know why that is the case. Height is 10, yeah. Length is 5. Width is 2. 5 by 2 by 10, 100. Dimensional weight is area of base of box, length times width. Alright, maybe that was it. I don't know why that is though, I really don't. Alright, so we're going to forget about that anyway for now. I'm not sure what's going on there. But honestly, if I just had to use that instead, it wouldn't make that much difference to me. So yeah. We can do the same test that we did before. Well, not really actually. But you can obviously do this length, do some bigger numbers. And get some computations there. There we go, you can see 200 times 500 is 100,000. So yeah. Okay, that's fine then. Okay, so what's next? Well, yeah, I mean that was, I don't know why that happened, but at least I guess at least the error message was helpful. So I guess not too much more I can say on that. Okay, so the next thing we have to look at is macro definition. Okay. Alright, so these are to do with pre-processing directives. Alright, so let's try, okay, so here's the next program. And we're going to be converting from Fahrenheit to Celsius. Okay. So the aim is, like I say, to convert from Fahrenheit to Celsius. Okay, so yeah. So once again we're going to just we're not going to bother too much with this stuff on the box here. Okay, so what we need to do is we need to have macro definitions. So when there's a value like this line divided by 166 it's not clear, so you have to make it clearer. So the method we're going to do is and again this is again to do with the problem of truncation. But the problem is that to get an exact result, we need to get an exact result. So we're going to need to use floats. Using floats to convert also using macro definition constants. Okay. So to do this, what we're going to need to do is get rid of pretty much everything we just ran. Alright. Let's forget about all this. Okay. So the way to do this is we've got more pre-processing directives. So it'll be a different subsection, I guess. I'll do hashtag. So this is interesting because we haven't actually even declared the variables yet. But here they are anyway. Okay. So there's our two variables anyway, but we needed this macro stuff. and the macro stuff is going to be definition. And these are all written in caps. Again, I'll probably focus on, there's a few things about uppercase and lowercase, camel case and all this stuff. I'm going to try not to use camel case though, I find it a bit annoying. And we'll define the scale factor. Okay. So yeah, this is how you would convert anyway. I'm going to be doing quite a lot of maths on this, I think. I'm going to be doing lots of different interesting things. I've actually got an idea for a game that I'm going to try and make as well, using some of this. It's a sort of maths game. Should be quite funny. Integer factor. Interesting, you did that. That's because I wrote it incorrectly. Yeah, there's no gaps. There we go. Now we see we've got it's purpleized itself. Okay. So yes. So what are we going to do with this then? We see that by doing this, it's useful because it means that we can actually put it in the text in a different way. At least we actually get to see what it is. So as far as like like this whole, I mean that was cool. Let's just review what we talked about so far. So print.f, what it will do is you do %d for an integer, %f for a float. If you want that float to a certain number of decimal points, we do say 2. It would be %.2f, and that would be for the printf, right? And then we do, then you do \n, and then you would close off the string statement. Then you put a comma and then a space, and then you'd have the variable that you're dealing with. Or in fact, you could put the expression that you're dealing with as well. So yeah, and then and for scanf, what you would do is you would first of all you would take the user input first of all, put that in the quotation marks. %d, but what you then do is you would you'd actually store it into the integer by the ampersand, and you would have to take it. If you were taking an int, you would do it would basically be %d at I, and then if you're taking a float, it'd be %f at x. And keep in mind, of course, the reason why these things are the certain letters are used as they are is because there's certain different letters for different types of value. That's a mathematical idea there. And I'll actually I've actually got something I can think off the top of my head that I can actually use to illustrate that more clearly. Something I was doing in my maths videos in the channel. So yeah, with regards to this anyway, what we're going to do is we're going to you see, the reason doing it this way around, and what I might do is I might actually do it the other way around. That'll be interesting to try that. That'll be an interesting thing to do, because what I've got here is I'm just going through a chapter here, and I'm going to try to do a lot of different tasks within this chapter. And once I'm happy with that, then I'll move on. But a long way to go, let's be honest. It's going to take a very, very long time to do bloody anything. But hopefully, maybe I'll get faster. I don't know. I generally don't know at this point if I will get faster or if I've reached my ceiling of ability. All right, so we're looking for not that. Enter the Fahrenheit temperature. Okay. Alright, so if we're going to put it into the Fahrenheit temperature, we need to actually get it from the user. So to get it from the user, we use scanf. I wonder if it's going to say the same thing again. I'm going to try it normally. If it does say the same thing and I have to use that, there may just be a secure version of it, which may not make any difference to functionality. Hopefully that is the case. I think it probably is. Okay. So we're going to take this number, and this time we're going to take it as a float. So we're going to take it, so remember the percent is to take it, close the quotation marks, and we store it in our already declared variable. In this case, the declared variable we've got is the Fahrenheit variable, and we're going to stick that right in there. Okay. Now what we're going to do is we're going to do the processing on it. So the way to process Celsius and to get it from Fahrenheit is we have to use these this macro definitions that we've already established, which are the freezing point and the scale factor. So the way to convert from Celsius to Fahrenheit is and we see we can do the operations differently as well. Probably what I'll do here is actually incorporate a line going backwards as well. That'd be an interesting thing to do. Freezing point, there it is. So Fahrenheit minus the freezing point is 32, because 32 degrees Fahrenheit is 0 degrees centigrade. Okay. That's just something which I happen to know. And we'll times this by the scale factor. And that should be all we need to do here. Yeah, looks good. And you see, what we do is we only concatenate the ends, because if we you have to be dealing with floats the whole way through the process. So there's already reading through this program, there's a few additions that I might make here. Celsius equivalent. All right. So we said what we mentioned before. Well, 1 decimal point, and yeah, and then we want to move to a new line. Working out when to move to a new line is perhaps going to be a bit of a tricky situation. But that's something which hopefully will come in time. So yeah, so what else is there? Not much. Oh, I've already got one. Let's have a look. C declaration. Why are they saying that again? Alright, you know what, I'm just going to use that then, I guess. I think I probably could turn it off somehow, but I can't seem to work it out at the moment. But it seems to work if you turn it off. Let's try it. 32. No, it's not working, is it? Something's working, but it's not quite working. No, I'm not seeing any problems here. Freezing point, scale factor. I copied that in. It looks good to me. It does look good to me. whether the Scanf is doing something wrong with getting the Fahrenheit. Let me try and actually let me just check it actually gets there. So and then what we do, it's going to be and then we print out the sorry, let me just check this. Yeah, it's getting there. Yeah, it's getting there, right? So Celsius is Fahrenheit minus the freezing point times the scale factor. Why isn't that not working then? No, I've done that stupid thing. I don't know why I keep thinking of doing that. It's not storing it into Celsius correctly, is it? I'm not getting any errors from this at all. Why is this line not working? Yeah, that makes no sense, does it? Fahrenheit is 200, it's a float. Let me just put the numbers in here for a minute. This must be what the problem is. I don't know why it's not working. Sorry, let me just, I may have just missed out something. I'm not sure. No, I want that to work like that. I'm sure I've done nothing wrong there. It's not better. Maybe let's just stick with fucking numbers than that stuff. No, it's still not working. I've done something differently? The only thing that's done differently is this fucking thing. That seems to be buggering it all up. What if I do that now? I may have to look at this. Yeah. I've got no idea why I can't get that to work there. I know it will work somehow. Now what I might have done is, you know what, I'm going to leave the scanf thing, because I'm not sure it makes any difference for something like this. Did I somehow do something wrong with the definition of them? I just don't think you define them. Let me just check something quickly. What's missing there? No, I think I just buggered it up here. It's annoying though. What is scanf? Oh, we need .1f here, don't we? So I go back to where it was. Yeah, that makes no sense to me, how that is not working. Looks fine, doesn't it? So I could put brackets around it. I don't know if that makes any difference there. It's not seen. It doesn't seem to work with any of them. Fahrenheit, Celsius, Celsius, Celsius. Celsius looks correct. Have I capitalised it by mistake or something? No. I'm not sure what to do here. Alright. We've got our Celsius. Wait a minute. Yeah, sorry, it's just taking me. It's going to take me bloody forever for some reason. So we know this is a float as well, right? I mean, are they actually going to let me? Uninitialized local variable Celsius used. Really? I guess I only declared it, I didn't initialize it. But can you initialize it as part of, as actually going into a statement? You see, I wonder if I just did that. You see, it's happier like this, and I wonder if it will actually work now if I just initialize it there. Let's change it up. This is getting fucking messy as hell now. But I just don't understand why I didn't initialize it. I bet it works now. It's got a feeling it will now. It does. Yeah, it does work now. But it's funny, it didn't work until I initialized Celsius. Oh well. But you see, I mean, to be honest, it's like I would expect. I mean, I'm happy with it being like this, but it does make me wonder why it wasn't. It's this issue with the macro definition. I think is causing problems. I don't get why I have to define Celsius here. Why I have to initialize it. I mean, I don't have to initialize Fahrenheit. I suppose I can't initialize Fahrenheit because I'm scanning for it. I think I can actually initialize it on the same line as well, can't I? Alright, I'm going to have to look at this more though. At least I've got it to work. So yeah, I'll look at it more. And there's a lot more things I'm going to need to do here. So yeah, thanks for watching.